the overview of ANSYS workbench. Basically, just a very quick introduction of just to show you the interface, the graphical user interface of this workbench. So you know where to find and how to start later on. When you click on the workbench, ANSYS workbench, then you will have this graphical user interface, and it is divided into two primary sections, where you have the toolbox sections and also the project schematic sections. So this toolbox section basically is where you find the analysis that we are going to perform. Okay, for example, stress analysis, vibration analysis, or even you are going to acoustics. Okay, so all can be found from here. This project schematics toolbox, these sections, this pane itself is more towards your own projects layouts. Okay, so once you have you can customate your own what we call projects or analysis that you are going to perform or analyze. Okay, so it could be one analysis, or it could be a combination of one or two analysis where we set the coupling effects between one analysis to one analysis. So under these toolbox, you will see that there are here subgroups, okay, analysis system, component system, custom system, and also design explorations. So when we are talking about the main part, like static analysis, dynamic analysis, usually it can be found from these analysis systems. So these are all the predefined analysis template that can be placed in the schematic. So whenever you see the analysis later on, when you expand this drop-down list, okay, click on it, then probably you will see a list of analysis. Then these are the analysis that if you interested on analysis on statics, then probably you can drag and drop into your project schematics section, or what we call the pane. Component system is more towards small components like blades or specific components, rotor blades that could be available and here, okay, components, various applications that can be accessed to build or expand your analysis. So basically, it helps to expand your analysis. So for example, you have a rotor shaft system of your so-called here is talking about gas turbines. So particularly on the blade itself, then you can expand the analysis on that. Custom system is more towards when you want to do couplings, okay, between example statics, structures, and also the fluids. So that is some of the module that you can pull it out to your project schematic to link. Design exploration is more towards optimizations. So if you have times on end of the semester before we finish, probably I can touch a little bit on how you optimize your design, because currently I see your case because it's 2 credits, then we don't really and also because of the course learning outcomes, we don't really touch on how we optimize our design using finite elements. So here is more towards optimizations. Okay, so if you have times, then and you feel like you want to learn more, then probably we will look into how to optimize our design based on the analysis results. So for example, the stress level is that much. Okay, let's say you have a 200 megapascal. So you want to optimize your design, okay, on certain parameters, okay, the length, the thickness, so that your stress level, it won't it come below 150 megapascal, something like that. So what you need to optimize, so that is more towards this. So from design exploration, you can find a couple of what we call analysis that can be used for optimizing your design based on the result from the finite elements, right? This is the toolbox. So if you look in a little bit into toolbox, when you click view all or customize, then there come a list of customization of the analysis available. So of course, it will give you the full list. Okay, depends on the version that you have. Okay, the license that you have. Then of course, if you do not want so many things, okay, you are focus more towards structural, then probably you will choose select, okay, select those that related to structures. Then yeah, so whenever you click on the tick on here, then it will appear at here lah. Else the drop down list will have a full list of the analysis. Okay, so of course you can do your own customization, or if not, then you just view all. Then you will have all. You click on this plus just now, you will have this full drop down list. Okay, so this is more toward the components. Okay, like I mentioned to you. Okay, you have the turbo machinery. Okay, related. Then CFX, the blade. Okay, this is all more towards the components. And also our mechanical APDL is one of the component of the analysis. It will be a separate windows or separate analysis systems, okay, from the workbench. So like you have this static later on when you going towards the analysis, it will open this mechanicals, or here if you are involving so-called some codings related. Okay, this APDL is the ANSYS coding. Then probably it will open a separate window from here. Okay, so this is a component system. So you can do your own customization basically from here. Then the project schematics pane, or what we call the section, is basically is a graphical representation of your workflow. Basically, it's more towards the analysis that you are doing, and it come with a flow that step by step that you have to complete this before you can move to here. So later on, I will show you in the graphical manner also. The workflow is a project schematic is always left to the right. There are currently several applications with our native to workbench, meaning they are entirely run at the workbench. So you have this engineering data, design explorations, mainly on the workbench. So in the case of you are going towards analysis, so now you have this, if you click on it, then it will run in a separate windows, or what we call the components. Mechanical ABDL, ANSYS, CFX, Fluence are all a separate so-called windows or applications. Okay, so if you want to delete, so you right click of your mouse, okay, right mouse click, then on the block header, then you can delete it lah. So this is the project schematic section. So if you look into this, so this is your toolbox section. So if I'm interested on this static analysis, okay, so static structural analysis, then what we do is usually you point your mouse to here, then you double click on it, then it will appear this analysis, what we call workflow, in your project schematics. Okay, so or the second method is you click on it, then you drag this module to this side, then release your mouse click, okay, left click, then probably this thing will appear the similar things as seen here, right? So this is the flow lah. You see 1, 2, 3, 4, 5, 6, until 7. So first, that is the flow that you need to complete before you can get a full results lah. So more towards their user interface lah. So first you have to set your material properties, engineering data, okay, available in your models or in your system that are under analysis. Then you have to have a geometry, meaning your model. So either you can import from third-party CAD modeling software, or ANSYS itself, they have two modeling tools that you can use. Okay, so you can model inside here, or you can import from any modeling tools like SolidWorks. Then once you click on, once you have completed, then you have a tick, then you can move to the this number 4, which is more towards analysis. So when you click on it, then it will open a separate window, like what I mentioned to you, mechanicals. Okay, so this mechanical is more towards analysis lah. So you click on this, before you start analysis, you have to do the setup lah. So the setup will be when you click on this, the model, okay, will automatically being loaded in the mechanicals. Okay, whatever that you have put at here, then it will be loaded in the mechanicals. Then the setup here, when I said this setup, it's before you start performing this analysis or final element analysis. The setup that I have mentioned to you, you need to have the dimensions, which is the model itself. You need to have the correct material properties that you have to assign to all these models. Okay, you need to have the connections, or what we call how they are being bonded, or how they are being connected. You need to have the loading. You need to have the boundary. Okay, how they're being fixed. Then you need to discretize it. Okay, into elements. Okay, so all these setup have to be done. What I mean here is pre-processing phase before you can send to the solver to solve it. So once you have solved it, probably you can call out whatever result or the output result that you want to look into, deformations, stresses, even here later on we'll look into the factor of safety, in terms of failures analysis, all can be called out under once it is being solved. Post-processing will be easy. Okay, so again, under solution, it basically build up the matrix against what you have built, the models from the model that you have built, and from the number of elements on the node that you are available, or how you discretize it. Then it solve it. Then you can call for any results. Right. So this is what it calls its interface. Then yeah. So how you drop it, basically you double click it, or you click on it, then you drop that particular application to here. Okay. So what you can do is, okay, just now what I have mentioned to you is you double click, that is the individuals. Okay, this is an individual so-called analysis. So only applicable to statics. So in the case of you want to share your results, okay, let's say I'm performing thermal analysis, then I want the effect of the temperatures towards the structures, stress analysis, then probably you have to share your results. Okay, these two analyses have to be coupled. So meaning you have static analysis and you have thermal steady state analysis. Then probably you have to link between them. Okay, how to link them? Probably you, like what it's stated here, you have to drag the analysis, okay, towards your mouse pointing towards what we call the analysis that are available in your project schematics. So in that case of, let's say, I just want to share the geometries, okay? I do not want to share the result from the thermals, okay? I have this individual thermal system already run, finished, okay? Then I want to share the same model, okay? I want to analyze on the stress analysis statics, okay? So what I do is I click on the static and I drag towards here, then it will come out with this red so-called, depends on when this basically red box appear, meaning what level, okay, you want to share your informations. Okay, so you see here will be a share. Okay, that is a share. So it say that you are sharing A2 to A4. Okay, so meaning to that you are only share up to the geometry, or what we call the models. Right. So in the case, if you drop it, okay, once you have select into this red, okay, square, then you release your left mouse click, then probably you will have something like this. Okay, between these two, in your project schematic, it will have a line link between them. So meaning to here, whatever I have changed the model, okay, if let's say I change to other geometry or update my dimensions, here will be automatically updated in your static analysis. All right, so that is here we are saying that no thermal or structural coupling, or meaning to that the results or the solutions from the steady state thermal have no effect towards the static structures analysis. Okay, so in the case of you, let's say you want to share, okay, the results, okay, from the temperature analysis, okay, the thermal analysis towards the statics, then static structural analysis, meaning I would want to see the effect of probably thermal stress, okay, onto my structures. I need to take into consideration of the effect of temperature or thermal stress. Then probably I need to share the solution. So what I need to do is I click on the static analysis, then I drop, then I choose. Okay, you drop it until your mouse pointing to the solutions. It will automatically tell you, okay, what you are sharing. Okay, so you are sharing A2 to A4 and transfer the results, okay, the solution of A6 towards that. Okay, then you release, then instead of the 3 line, okay, sharing A2 to A4, then you are sharing the A6. Okay, you transfer your A6 result to the setup of your B, which is the static structures. So meaning to that, whatever that you have done here, the analysis from the thermal analysis, okay, will be used as a input, okay, or setups, okay, in initial setup or initial parameter for your static analysis. So here we are saying that they are coupled, okay. They are coupled, meaning your analysis structural system that is coupled to thermal solutions, right? Or another way, of course, what you can do is you right click, okay, right mouse buttons. You click the right mouse button, then you transfer your result, the solution of your thermal to, let's say, statics. Okay, can be done also. Right. So you will see if you are having a workflow like this analysis, you see here you have many symbols or icons here, basically. So if fully completed, then you have all tick, okay, the green ticks on here. So if you have any question mark or others symbol or icon, then probably you need to take some action or actions needed for you to complete lah. Okay, so these are some of the icons or to identify lah what is the problem. So this we would want to see this up to date, meaning everything is rerun or completed lah. So in the case of, you see this attention required, meaning you need to do something lah. So here, if you see this a solid question mark, basically you need to correct this or upstream cells. So when I say upstream cell, is meaning here. Okay, so here if you click on this is your upstream lah, basically. If you are at here, you see this icon, meaning you need to double click on it and see here, meaning you do not have any geometry yet. So you have to import your geometry, or you have to draw or model your geometry at here. Okay, so when you have the model, this will be have a tick at here. Okay, a green ticks. So that is attention required lah. So if you have this, meaning you don't have upstream data. So if you go in towards here, if you see here, these are all the question marks that you see, meaning you don't have any information at here in your upstreams. Okay, so this upstream of this is this one, geometry. So meaning you cannot read any geometry, okay, from this particular mechanicals. Okay, under mechanical, I cannot read any geometry or any dimension or any models that available for analysis. So you need to import the geometry. So sometimes you have changed some things. Okay, we have made some changes on my dimensions, okay, model. So you need update. You need to update it. So sometimes you will see this. Okay, so the data have changed and the output of the cell might be regenerated. So sometimes you have changed it, so your results, your analysis result have to be updated. So you will see some sort of this thunders icon at here. So you have to rerun back your so-called solutions. So if you change some things, okay, data have changed. Okay, so if I manage to let's say here, I initially I have a tick here, geometry. Okay, then I went to change the thickness. Okay, so then it will have a tick again. But here it will have the refresh. Okay, refresh, but the refresh icon that you see here, because you have changed something. Okay, upstream data has changed. Your what we call your model dimension has changed. So you need to actually refresh or update your whatever models. Okay, in the following downstream cells. Okay. So same with this lah. If input change, then you will see sometimes yeah, you need to update again whatever that is not updated. So probably if you change something, you insert the loads change. Okay, let's say from 50 Newton I change to 55 Newton. Then yeah, you will see some sort of this icon. Then probably you have to re-update back your everything again. Right? Then if you look into the properties under geometry, okay, later on I will show you under geometry, then probably you will see if you go to view property, then there is a window that to tell you what analysis that you are looking into. So you tick solid bodies, surface body, line bodies. So depends on what bodies you are actually looking into. Then analysis type, this is on under geometry. So analysis type are going to 3D, 2D, or whatever. So if you are looking into 2D, then probably elements type of 3D element types or three-dimensional element type, probably you will see you have no choice or selection options over there later on. Right? So that is the property that you can further additional settings. Then if you go to the here, this is under view. Okay, under unit, you can change or customize your own unit systems. Okay, so here, if you look into it, there is the SI matrix, yeah, US customary. So if you think that some of the system, some of the unit system, unit use is not similar with what we are using, okay, then we can create our own unit system. So what we need to do is we click on the unit system, then of course, we create our own unit system. So the easiest way is you duplicate the closest one, okay? The closest one to what you have, then you duplicate it, then you change whatever at here. The sum of the units maybe is not similar with what you are using, then you can change. Okay, so we don't create our own from scratch, but probably the easiest way is to duplicate from the existing one. All right. If you go into ANSYS, okay, then you will find for the workbench. Here is the workbench. Okay. Then if you click on it, okay, if I have a new project, new project, so you will see something similar like what I have mentioned to you. Okay. Okay, so that is a project schematics section. This is the toolbox sections. Okay, so on top of this, you have the view, you have the tools, you have the units, like what I mentioned to you. Okay, so if you want to go for units, then you go to unit system, right? So you duplicate one that closest to you, then you can change. Okay, later on you can change. So the existing one you cannot change basically. Okay, but once you duplicate once, then you can change your own one. So if let's say here, duplicate one at here, then probably you can do your own changes at here. You see, now it's enabled, then you can change. Right. So I delete this. Then the analysis is the toolbox. Under toolbox, we have all the analysis system. So if you click on this, so these are the available analysis that we can use. Okay, so you see that from fluid flow, from the thermal, from the statics, even have acoustics, you have magnetostatics, IC engines, a lot of things. Okay, you can play around, right? So under components itself, these are the additional components that I tell you. Okay, I told you before just now. Fluence, more towards yeah, mechanical, APDL, okay, that you can add on, okay, to your existing. The custom is where you custom system is where you do the interfacing or couplings, okay, usually particularly couple it. Design exploration is the one that I told you in terms of optimization. So you can use this to optimize your designs. So if you have time, we can look into this response surface optimizations later on. So it will be coupled with whatever that we have here, statics or any analysis. Okay, if we are talking about stress, then or talking about fatigues, then you factor of safety, then you can use it as a objective functions to update your parameters of your dimensions. Okay, so like what I said, okay, here in this course we are more towards structural or solid mechanics. So the main, I think, what you can see, the analysis that we are involved as will be static structures. Okay, Then you have probably model, more towards vibrations or dynamic analysis, then towards harmonic response. Okay? These three. The main one is these three. Of course, you can go to, we will talk a little bit on the structure, but on transients, then and harmonics, then probably if we have this explicit dynamic is more toward some sort of impacts, more toward transient and impact things. Okay, so we could have looking into that. Okay, if you have times, but our main focus is static structures, model, and what we call harmonic response. Okay, so what I need to do is I double click. Okay, static structure. I double click it. Okay, it will come out with this. Or I click on this. Okay, I drag to the green pane. Okay, where you want to put it. Okay, so you see if you click on it, you click on it, then you click on it, you will see all this green box at here. So it's where you want to put on it lah. So if you put on it here, then yeah, you will come out another analysis called B. Okay, also statics. Okay, and you see that it doesn't link to each other. They are standalone. Okay, so in the case of I have steady states. Okay, then if I want to link some of the results, okay, or I want to perform model analysis or vibration analysis, but I want to share my models, okay, so with my static analysis. So what you can do is you click on this, okay, then you move to here. If you move your mouse move to here, then you will see this, you have a share here. If I move to here, it's a standalone system. If I move to any of these, you will tell you you are sharing some results. Okay, so now I'm sharing B2. Okay, then you drag until B4, which is until your model, everything. So you release, then it will have the up to your model will have what we call your geometry. They'll be sharing together. Okay, no result will be sharing in this case. So in the case of I want to share my results, okay, like what I mentioned to you, the thermal couple with what I call statics structures. Then what I need to do is you click on the statics. Okay, if I click on the static, then I go to here, then you see that it will share D2, D3, D4. Then if you move to here, then you will say transfer D6. So if you release, then you have all this line, okay, sharing the model as well as the solutions to the inputs of statics. Right, so that is what you can see. So in terms of geometry, so if I have, you right click on it, okay, so you can import, of course, you have any geometry available in any forms, okay, SolidWorks form. So if you look into this, it recognizes a lot, very wide range of file, CAD file, okay, so you can import, okay, from here. Else you can make use of its internal modeling tools. Here, this is a design modular geometry tools. Okay, so this is one of so-called existing or older one. Then you have this space claim geometry tools. Also, is a better versions, more so-called user friendly. Okay, interface friendly. Okay, so our course will mainly on design modelers, okay, but I have some tutorials or some case study where you can use space claim to model it. So, but bear in mind that, I mean, our course is not towards modeling, so we are not teaching how the techniques of models, okay. So here, our analysis model is very simple, not too complex model. It can be done, not really have to require third party like SolidWorks, but it can be done in this design modeler or space claim. Okay, it can be modeled easily at here. Okay, at the end, what we want to focus is more towards the analysis parts. All right, so let's say I import models at here. Okay, so if I click on this, I have a model. Okay, so I click on this. So you see that there is a tick here, geometry done. Then you need a refresh, okay, in your model. So if I double click on it, okay, it will go towards this starting mechanical. So as I mentioned to you, this mechanical is another window or another platform. So it will go into another so-called from workbench, you open to a mechanical where your models will be imported or your geometry will be imported, right, to this for analysis. This is where we do this, or this mechanical is where we do all the discretization, input loading, boundary for us to run the simulations. Okay, so from here, if you look into it, uh, go back to the A here model. So you can see that you have the engineering data being set. So if you double click on it, it will open in a workbench. Okay, here. So you have structure still. Of course, we can add more so-called material if you want. If let's say in my system or in my model, I have other two type of material. So probably you can find from here lah. General is a library you can find. So if I have a stainless steel, you can just add on it. Okay, then probably you will see a stainless steel at here. Okay, so this structure steel, stainless steel, you see that it will give you a list of its so-called default material properties, and we are more so-called towards solid mechanics and linear elastic analysis. Then here you will have this Young modulus, Poisson ratios, density, the main properties that you require. In other words, in the case of you are going towards failure analysis, then probably you need the strength of the materials lah. Use strength, tensile strength. If you in the way of you are going towards fatigue analysis, then you will need this SN curve lah. So this SN curve of this material will tell you will be used to evaluate when it will fail in terms of fatigues lah. These materials. Okay, so these are the material that you can set and you can change according to your real materials, okay? Or you can even create your own material properties lah. So it's open under workbench, right? Then you have this material, you have the geometry, then you have the model itself just now, right? So just now I click on materials, right? Then you need additional refresh again. So if click on it again, you have upstream data need to be reread because I have clicked on the engineering data just now. I changed a little bit. So you have to be basically re-update, refresh everything, right? So here is where you have your geometry. So if you have two parts, okay, in your assembly, then it will separate into two parts lah. So each part have to be assigned the materials. Okay, so here just now we have from the library we call out structural steel and also stainless steel. So from here you can choose lah. Okay, so if I want stainless steel, then I just assign it as a stainless steel. So part 2, part 1, part 2, I also put stainless steel. Let's say. Okay, then these are the materials that we have. Then probably you have to go into the connection. So a lot of time, if you have in your SolidWorks, let's say you have assembled it, right? So usually they are in contact. So if you look into this, okay, this itself and the shaft is in contact. So ANSYS, when it import into this mechanical, it will help you to predefine the contacts. Okay, so the default contact is bonded, so they are like welded. Okay, meaning to that here is no slidings. Okay, between this and this, we have no sliding allowed. You have no separation, meaning this and this, it won't be separated. Okay, these two surfaces won't be separated. So this is the highest so-called contacts levels. So of course you can choose different type of contacts. Okay, so that is the things that are auto-defined by this mechanical, but then you user can also define yourself. If you think that it's not bonded, then you can change it. Okay. Then you have the mesh. Okay, so the easiest way, of course, you can set different sizings, the quality, all you can set, but then you will have a auto generations of the mesh or discretization of the elements. So if you do at auto, then it will help me to discretize by itself. Okay, so you will see that these are all the elements, these are all the nodes, right? Then probably under static, you have the context, you have the mesh, you have the materials, you have the dimensions. Then here you need to put in the loading and also the boundary. So here you have to insert any loads. You go to right click or you click on here, you'll see you have a loads and you have the supports button here. Okay, you can choose whatever loads and support that available. Okay, that's suitable for your analysis, right? So once you have insert a suitable loads, suitable supports, then probably you can run the analysis. You can send it to solve. Okay, solve. So when you have solved, or before you solve, you can also call out the output that you want to look into. If I want to look into the total deformations, then you just right click or you click on the solutions, you are lead to the solution menu. Okay, so these are all the solution that you can call it out. Okay, or you right click onto the solutions, then you go insert. These are the insert the tools that are the analysis or the result that you can look into after the solutions. Okay, it's more toward post-processing. You have this strain, you have deformation, you have stress, you have even the energy, strain energy. You have even looking into the fatigues, you have the analysis of statics, all are here. Okay, so if you're looking into the static itself, then here you can call out the factor of safety. Okay, so you know that whether it will fill into a static or not. Right. So this is where later on we will look into more details lah. Right. So once you have done all the setting, okay, then probably you can start the solutions. So you click solve. Because I now, you see that now I didn't really insert the inputs and also the under here I didn't have the load and also the support. So probably you cannot run. Okay, you see that you're not able to run. You need a loads and also a supports. Okay, in this particular analysis, static analysis. Okay, because you need to look into the effect of weight or the loads itself towards the structure, right? Then look into that when you only have deformation. So either you use the weights, okay, itself, it have to be negative y, negative this thing. Let's say you can change the unit, of course. Okay, if you think you want to change the unit, so I change to here, then probably it's easier, right? So you can change this towards directions of negative y. Then you know that. Then that is your load lah, basically, load of the center gravities, right? Then probably if you have a support at here, okay, so you click on this particular side, there is a supports probably at both sides. At here, probably you have a here, if I choose insert a fixed support here, okay, one face, then I can choose another face at here, the other side face, then probably I can solve it. Right, so this is purely no external load, but the weight of the using the weight of the rotor shaft itself. Okay, so in that case, you can see that the total deformations, right, of this rotor shaft, okay, it will deflect okay, about 5 mm, okay, 5 mm maximum at this size. Okay, so in terms of factor of safety, it's still safe lah. You see that it is at around 5.5 lah, right? So in this case, it's still safe if it's just statically loaded, okay, with the weight itself, no external loads. Okay, so that is how you can play around later on. All right.